So I'm going to start with two kind of just quick part examples. These are really kind of zoomed in and cross-section views of a couple castings we've worked on. This one is an aluminum part. It's about 6 by 6 inches or so, and we're sectioning into the casting itself. It is used to hold weight of a person, kind of help to build a step. If we look at the image on the left, this was the original model that we got from our customer. And the image on the right is, through the DFM process, what we went and changed. So I guess the first thing I just really want to mention is that, one of the questions that came up, I think a couple of times even before this was, we need to design a part for our process or for what we needed to do. DFM, of course, is important, but how do we mix the two? And, one of the big things that we can do to help that is really getting upfront as early as possible. We can definitely steer you guys in the right direction, make those big critical changes as early as possible. But realistically, too, a lot of the times the DFM that we do is going to be relatively minor things that are going to have a huge impact in the part quality, tool life, and just the manufacturing process in general. This one's a great example of that. So in this part, it's sectioned into the casting, so we're kind of like taking a cross section of it. And you can see in the left view, there's this kind of large indentation or large chunk taken out. That's a section view of a metal saver, which is utilized to help thin out the wall thickness in thick sections, which we'll get into a little bit later in detail. On the right side of the view, we've actually taken that metal saver and reduced it dramatically. Normally, you want to pull as much material out of the casting as you can, but what happened with the specific one is it actually created a thin wall condition on the inside edge of the casting, which could lead to possible flow-related issues. It could even be a hole in the casting as it was quite thin. On top of that, we need to create tool steel in order to form that metal saver into the tool itself, which is a really tall, kind of proud piece of steel that could have gotten damaged, broken, bent, that kind of thing. So really what we ended up doing is really reduce that depth of that metal saver, increase the wall thickness to get a more uniform wall thickness, which is going to give us better casting quality, better flow. It's also going to improve our tool life, and it gave us some areas in order to make some ejector pin pads, which are these small circles. Again, we'll get into a little bit later as we get into some more details of the DFM. So it's a good example. I really like this one because it's just such a minor change that can have such a dramatic impact into how we would produce the castings for you guys and just how well we can make the parts. I've got another example, somewhat similar kind of part, similar process of what we were doing. Again, got the part, it was pretty good. A lot of the stuff we needed to get was in there. We just kind of needed to continue it and push it over the finish line. So the image on the left is the customer model again. A lot of different metal savers into this casting feature. It's a relatively thick area. On the right, what we ended up doing is we actually removed those 4 small kind of, pyramidal shaped metal savers. Again, the steel that would need to create those would be pretty small, very delicate, and we were concerned about really the longevity of the tool. We also took the current metal savers, increased draft and radii, which we'll talk about in a little, as well as added those ejector pin bosses again. So just another simple example of something we, took the customer's model, we changed it in a way that's much better for what we need to do to make the part, and with the minimal impact to the product function. In this case, no real impact to product function at all. We do this stuff every day. This is, what I do actually. My day job is, DFMs and analyzing castings for customers. So, we love this stuff. We love getting in early and love helping you guys with it. Let's jump into this just kind of overall DFM. What we're going to do is kind of take apart. We're going to walk it through a process. Going to talk about some of the main things we're going to be looking at and some of the main things we're trying to improve upon. Going to give some rough rules of thumb, but a lot of this stuff is very case-by-case basis, depending on alloy, part size, quality requirements, etc. But I will do my best to give some good, just rough rules of thumb, some rough starting points in order to help steer you guys in the right direction. We love DFM. We love helping you guys. Like I said before, we're more than happy to help. We love doing stuff like this as well. These kind of webinars. The information we're going to teach you is so valuable for us to have to make your parts better, but it's even more valuable in our eyes for you guys to have that knowledge yourself, to be able to do these changes up front and really get that casting going in the right direction. We utilize, a wide variety of expertise across all of our facilities for this. We have kind of a multi-platform teams that's going to always be working together. For DFMs in particular, about once a week, we're going to get all of our engineering managers together to review what we're working on in order to really fine tune and work towards a solution that not only works for one plant, but Dynacast as a whole. We also do utilize casting simulation software Magma for our DFM purposes, as well as developing the final process. So now really into the meat of it. So we're going to take a real simplistic part. We're going to kind of walk it through the process of how we would take the casting from maybe someone who had an idea of something they needed to do, and then work it towards something that's much more of a die casting. The part itself, you can see in the top left, is relatively simplistic. It's a kind of a rectangular cube shape with a couple holes in it, and there's an extrusion on the front, again, with a hole in it. This could be very representative of what we might get from a customer, or we might get a part that is almost a die casting, completely ready to go from a customer. So we'll see stuff across the board, and we're really happy to help at any stage of that. We definitely prefer to get in as early as possible to help with the designs. The first thing we're going to do when we get a model that we're going to look at, and especially if it's something a little thicker like this, is we're really going to try to thin the thing out. We're going to try to reduce the weight. We're really going to go for uniform wall thickness. You'll hear me probably say that a few times during this webinar, uniform wall thickness, and it's a really critical just kind of mentality in die casting. What happens in die casting is you're filling this tool steel with molten material, aluminum, magnesium, zinc, at a high velocity. And what happens is the outside of the casting itself solidifies first. So that's what changes from the liquid to the solid first. And then it actually starts to solidify, kind of working its way inwards.